Okay, class. We're going to continue with Miss Kennedy's book here, her journal. We're going to look at hurricanes. Real quick, real basic, not a whole lot that you have to really get. Your most important thing about hurricanes, their formation is over warm ocean waters. It really has to be over 80 degrees Fahrenheit. 80 degrees. This says 85, but I'm telling you, 80 degrees is what you'll be tested on. It provides energy, causing evaporation to occur, which supplies the water vapor that gets the hurricane up and running. The winds come together and force water vapor upward and outward above the storm. More water vapor to rise, and the more water vapor, the higher the pressure, and then we just get a massive storm out of it. Once the clouds begin forming due to this water vapor being carried by the winds, then the storm really gets strong. Light winds outside the hurricane zone steer it along and allows it to grow. The warmer the water, the more energy the hurricane gains. Remember this right here. Two things. One, that the water temperature has to be above 80 degrees. And secondly, the warmer the water, the more energy. And so here's kind of how this looks. Hurricanes rotate counterclockwise in the northern hemisphere. You have the Gulf Stream. You have the entirety of the Atlantic Ocean spinning here. Hot air rising and coming back down shooting major thunderstorms off of the western coast of Africa into the Atlantic Ocean. And as that goes into the Atlantic Ocean, those storms get that warm Atlantic Ocean water. Notice it's right there along the equator. The ocean, and the storm builds, and then comes up and it rams or goes into North America. Jet stream pressures, air masses coming southward and eastward across the United States will cause a hurricane to even turn and go back out into the Atlantic without ever touching the Americas. A lot of times, though, that in the summertime, that jet stream's high enough